Hey guys, welcome back. So today we are going to delve into mastering carbon numbering, the key to naming organic compounds. So how do we number carbon atoms? To name organic compounds, we need to number them, right? So let's start with the basics. First, we need to identify the longest continuous carbon chain in your structure. So this is called the longest chain rule. We can call it as the longest chain rule. Okay, so what you need to do is, first of all, you need to count the number of carbons in that chain, and this chain will be called as the parent chain. So here in this case, let's number it 1, 2, 3, 4, and 5. Now, how do I number it? Should I start numbering from this side to this side, or from this side to this side, or randomly somewhere in the middle? So I need to decide on that, right? So for this, you need to understand that there is this longest chain rule. Either you number it this way, or you can also number it this way: 1, 2, 3, 4, and 5. So now when I number it, I get 5 carbons in this particular structure. So 5 means the root word is pent, and I don't find any other bonds except for single bonds. So my suffix will be ane. So the name of this compound is pentane. So remember, if it is a single chain, like here, if it is a single chain without any substituents attached to it, you can number it any way you want. Either you number it this way or the other way. It will be called pentane. Okay, so that was easy. Now let's look at the second example. So here we have the compound, the structure given, the displayed formula. So let's start using the longest chain rule. So here we go. It's 1, 2, 3, 4, and 5. Now we don't number the chain. We don't number the chain. So this is the branch. So we don't number the chain. So we see which is the longest. Either we number it like 1, 2, 3, 4, 5, or it should be 1, 2, 3, 4, and 5. So remember, while you're numbering, the numbering should be continuous, and the carbons should be connected. So we don't number the substituent that is here. Okay. So now, because it is 5, again, it is pent, and we don't find any double bonds here. So it is an ane, so pentane, but we also have a substituent. Now, remember, we spoke about the alkyl group. Now, what is the alkyl group? Whenever hydrogen is dropped, like for example, if it is methane, if the hydrogen is dropped, okay, this is methane, and here let's say the hydrogen is dropped, one hydrogen is dropped, and it becomes CH3. So the name will change to methyl. So the same thing happens to any other hydrocarbon where a hydrogen is dropped and it gets converted into the alkyl group. For example, ethane becomes ethyl if it drops a hydrogen. So here we have the alkyl group attached to it. So this, this has to be, the position needs to be specified. So if you see, let's take this off now. And we need to put the substituent first. So methyl group, the substituent needs to be put first. And then we saw it is pentane. We need to specify the position of the carbon to which it is attached. So which carbon is the methyl group attached to? It is attached to the 4th carbon. So we need to mention the number 4 methyl pentane. But hold on. I can also number it this way, right? I can number it as 1, 2nd carbon here, 3rd, 4th, and 5th. So when I number it this way, I can give another name. I have another name for it. So the functional group methyl is attached to the second carbon. So it will be 2-methyl pentane. Now, I cannot have two names. That's really confusing. So remember that the functional group, now this is the functional group, this needs to be attached to the lowest number of the carbon. So which is the lowest number here? Now, if you take this carbon, which is the lowest number, 4 or 2? So 2 is the lowest number. So my name 4-methyl pentane is wrong. I will not use this name. So this is not the structure. It is 2-methyl pentane. So remember, the functional group should get the lowest number. It is just to make it easy. The goal is to give the functional group the lowest possible number. It's like choosing the shortest route in a maze. Quickest is the best, children. Quickest is the best. So once you've numbered the chain, naming becomes easy. So here you got the second carbon, and then you know this is the methyl group, and the parent chain, the number of carbon atoms in the parent chain will give you the name. So this way we will be able to get the names of the carbon atoms. Let's do a few more examples. Try naming this compound, pause your video and try doing it. And if you have completed, let's see if you've done it correctly. So the first rule that will apply is the longest chain rule. So that's the longest chain rule. So how do you count the number? So you count it this way. You can count it as 1, 2, 3, 4. So that will be 4. So let's try counting it this way. 1, 2, 3, 4. Okay. But we can also count it this way now. So it is 1, 2, 3, 4, 5. Oh, wow. So this is the longest chain. So either we number it this way, 1, 2, 3, 4, 5, or we number it the other way. Let me use another color so that it's not confusing for my students. So 1, 2, 3, 4, 5. So that's the first rule that's done. So we have 5 carbons. So 5 carbons mean it is a pent. And do we find any double bond here? No, they are all single bonds. So let's add an A in there. Now, where is the substituent added? Now, this substituent, what is the name? We already saw this. This is a methyl group. So to which carbon is it attached to? So it is, it is attached to the third carbon. In either ways, it is the third carbon. So this is 3-methyl pentane. So the position of methyl remains the same. So this is how it is. So there is another example. Let's take another example. CH3. Try to work this out. Let's change the functional group this time. CH2OH. Finally, let's recap with this compound. So first, find the parent chain or the longest chain. So what is the parent chain here? So 1, 2, and number it. 1, 2, 3, 4, and 5. So we have the parent chain here or the longest chain. And then the number, the numbering should be done from the end closest to the functional group. So which is the functional group here? So this is the functional group. Remember, this OH is the functional group for an alcohol. It's an alcohol. It's a functional group for an alcohol. So my numbering this way is not going to work because we need to number it closest to the functional group or any branch. So this is not right. So let's number it this way. I'll take a red. 1, 2, 3, 4, and 5. So now finally start naming your compound based on these numbers. So we have 5 carbons, so it is pent, and then it is an alcohol. And where is this alcohol? It is on the first carbon. So 1, and remember the name for an alcohol will be all. So pent 1 all. So this is pent 1 all. So this is quite straightforward, children. Once you get a hang of it, you're going to ace this naming of compounds. So thanks for watching. Score stars. Please hit like, share it with your classmates, and don't forget to subscribe. Thank you.